In this video lab report, I will be discussing my observations of an object in constant velocity in the real world. I will also be walking you through the methods of observation and data analysis I used to compare real-world physics to that of a computer model I constructed using Python. Essentially, I'll be discussing how the ideas of constant velocity and Newton's second law can be seen in the world around us. Finally, I'll be discussing possible errors that could have occurred during my observations that could have affected how my results came out. To begin my observations, I recorded a dodgeball being rolled across a wooden deck at a constant velocity. I then imported the video into Tracker and used it to analyze what I'd recorded. After setting up Tracker properly, with the origin set so that it was at the ball's center, and the axis progressing in the positive x direction, I used Tracker to record data about the dodgeball's location as time progressed. Next, I used Python to set up a computer model of the dodgeball to ultimately compare real-world observations to the computer's data. In Python, I changed the Lab1 start file to accommodate for my observations. I changed the ball's mass, which was measured to be 0.68 kilograms, and plugged in the initial velocity. Finally, I added equations for Newton's second law to be applied to the computer program. After running the program, I took the recorded data set and put it into Microsoft Excel to be analyzed with the tracker data. After plugging the information in, I created a graph comparing the velocities of the dodgeball in the real world and the computer model. As the graph shows, the Python model data shows a slightly different velocity than that of the tracker data. To sum it up, the computer model does not 100% correctly predict the motion of the object observed. Nevertheless, the velocity is still constant, so Newton's second law still holds true. Essentially, there's no net force acting on the ball, and the initial velocity equals the final velocity. At this point, I'll be discussing possible errors that may have occurred during observation so that the computer's model data and the experiment data were different. The first of these errors is that the surface that I rolled the ball on could have had slight variations, causing the ball's path to be skewed. Secondly, when using Tracker, I may not have put the center of the tracker data point at the center of the ball. This could have caused the velocity to be slightly offset. If I had done things differently, say used a better surface or truer selection points in Tracker, the real-world data could have matched up more closely to that of the computers. What if? If I'd flipped the axis so that the ball was rolling in the negative x direction instead of the positive x direction, the results would have been the same in terms of magnitude, but the numbers recorded would be negative, and the resulting graph would have a negative slope. As for what does it mean, we would not be able to properly say how many pushes and pulls would be added together to result in a zero net force in the observed case. The reason for this is because Newton's first law, inertia, would have to be brought into the equation and the computer model, as well as the tracker data, to fully understand the forces acting on the ball. In conclusion, the data I recorded in Tracker is supported by the computer model's predicted movement. This ultimately proves that the velocity of an object will remain constant given a net force of zero on that object.